unchanged. And the next one is decreasing the temperature of the equilibrium constant. Now, if you decrease temperature, the exothermic reaction is going to be favored. So, how do we figure out which one is the exothermic reaction? Now, to figure out which one is the exothermic reaction, there is no specific data that's given except for the value of Kc. Okay, except for the value of Kc, you don't have uh, it's not given which side which is the exothermic. Now you would notice that Kc value actually decreases with temperature. I mean higher temperature, I mean Kc value becomes smaller. So if Kc value becomes smaller, then that definitely indicates, if it becomes smaller, that indicates uh, that less products, because Kc is products over reactants. Now the only way it's going to be smaller is if you have less products. So Kc value over here, if you notice here, Kc value is becoming smaller. So that means backward reaction is happening. So this indicates that backward reaction happens when you increase temperature. Okay, this is what I've inferred from here. That Kc is 140, but when I increase temperature, Kc is 59. So that means backward reaction is happening. You're getting less products. So backward reaction is favored when you increase temperature. Hence, backward reaction is probably the endothermic reaction. Because whenever you increase temperature, the endothermic reaction speeds up. So in this particular case, Kc is the backward reaction is the one that's going to be endothermic, and the forward is the one that's going to be exothermic. Actually, is this clear to everyone how I figured out which one is endo and which one is exo? Is this clear? Rida, Sanjida, is this clear? Actually, so the next part is so that TK Sanjida, I'm going to repeat. The information that was provided was over here that you had Kc 140, and then you had another value of Kc which is 59 at two different temperatures. Remember, if Kc value is smaller, that means Kc is products over reactants, right? It's products divided by reactants. So if Kc value comes out to be smaller, that means you have less products and you have more reactants. If Kc value is higher, that means you have more products and you have less reactants. So if Kc value becomes smaller, backward reaction is the one that's going to be favored. Like Kc over here is 140, but when he increased the temperature from 500 kelvins to 650 kelvins, the value of Kc became smaller. It actually became 59. So that means as you're increasing temperature, the value of Kc is becoming smaller. Hence, backward reaction is the one that's going to be favored. Because the only way the value of Kc is going to be smaller is that if you have less products. Sanjita, do you get this part? And remember this, a lot of questions like these, they do often come where you have to actually figure out. So just remember this, that Kc, if Kc is only affected by temperature, that's the only thing that affects the value of Kc. So Kc is only affected by temperature, and if Kc value becomes larger with temperature, that means forward reaction or products are being formed. If Kc value becomes smaller, that means backward reaction is happening, and there are more reactants and less products. So this indicates a smaller value of Kc indicates at a higher temperature indicates that as you increase temperature, more backward reaction happens. Now the now according to Lee-Shatler principle, whenever you increase temperature, endothermic reaction is the one that's going to be favored, which in this case is the backward reaction. So more backward reaction is going to take place. More backward reaction happens. Now, more backward reaction is going to happen, and the backward reaction must be the endothermic reaction, right? Because at a higher temperature, endothermic reactions are favored. So based on this, we figured out which one is the endothermic reaction. The backward is the endothermic reaction, and the forward must be the exothermic reaction. Now we can go back and answer the question, which is if you decrease temperature, which reaction is favored? The exo reaction is favored. So if we go back and have a look, the exothermic reaction is the forward reaction. So forward reaction is favored. And as it is favored, so equilibrium shifts to the right. Okay, that is what they have asked. Is this clear to everyone? Minhail, is this clear? Sajida, Rida, is this clear?
Yes.
So equilibrium shifts to the right. Now, let's move to the next part. Remember, he's talking about 650 kelvins, and we have the value of Kc at 650. In the previous part, it's 59. So we have to solve for this now. And the initial moles are given. So we're going to find, we're going to figure out how many moles are getting reacted or produced. That's the middle row. Now, reacted and produced. Uh, we don't know how many moles are getting reacted. So I'm going to assume that X moles of H2 react. So it's 1:1. So if X moles of H2 react, then X moles of I2 would also react. And if X moles of H2 and I2 react, they're going to produce 2X moles of. These are going to be produced. And finally, we're going to find our equilibrium moles. So at equilibrium, we're going to have just 1 second. So at equilibrium, we're going to have 0.02 minus x. This would be 0.02 minus x as well. And this would be 2x. And you can then solve write the expression for Kc, which is going to be HI concentration squared. So it's going to be 2x squared divided by the concentration of I2 and H2. So it's going to be 0.02 minus x, and that's going to be squared as well. And this would be equal to 59. And you can then solve this, take the under root. And if you take the under root, it's going to be is equal to 59 under root. We can get the 0.02 over here and the minus x over here as well. So it's going to be 59 under root. And we can take x common, that's going to be 2 plus 59 under root is equal to 59 under root into 0.02. Okay, hopefully I've done the working correctly. So you're going to get two values. One would be with plus 59 under root, the other one would be with minus 59 under root. Tell me what the answer is. What is the value that we're getting? Mirahil solve किया? Just 1 second.
Sir, बस करिए 1 minute.
Sanjida, the other value as well. Rida, Heba need the value. That's value number 1. And you have to confirm whether that's. Rida, it's. नहीं, can somebody. Mirahil, आपने किया?
जी sir, सही है.
Need this one? Rida, can you Rida, can you check again?
हाँ sir, सही है ये वाली value.
ठीक है. अच्छा, anyways, we. Rida, can you redo this quickly? 59 and root plus into 0.02. This is into 0.02. Acha, and this value, is this the correct value? It's going to give you positive values. I think it's going to give you positive values. If you put this value, if you substitute this value into the expression, it's going to give you positive values. So I think you don't need to actually find the other value. Okay, spend time on the other one if the first one is not giving you positive moles over here when you try to find equilibrium moles. So Rida, did you get the same value? Yes or no? Even 0.027. No, it can't be 0.027 because honey, it can't be 0.027 because if you put 0.027 over here, it's going to give you a negative value. I mean, this thing would turn negative. So equilibrium moles can't be negative. Okay, the second value it looks fine. That it's coming out to be negative. Now we're going to try and so we're going to try and do. I'm going to try and do some tricky questions. 1 second. I mean, this is all about equilibrium. Remember one thing about equilibrium, and I've told you about this earlier as well. Just 1 second. Tiki, you can go through the worksheet and find the question. I'll just tell you again and repeat what I taught you earlier, that if there's a solid, then its concentration is always taken as 1. It doesn't really matter how many moles it has. The concentration would always be taken as 1. So for example, over here, if any one of them was a solid, okay, forget this 0.3 plus x. I mean, you can do all the working you like. Let's, for a second, assume that water was a solid in this equation. Then 0.3 plus x would not have been used. You would have used the concentration of water as taken the concentration of water as one. So remember this, that if you have any solid in the equation, its concentration is going to be taken as one. No matter how many moles it has, it doesn't matter. The concentration is going to be a constant. Solids have constant concentration, and its concentration would be taken as one. That's one important point. And the other point is uh, that if water had been aqueous, uh, if the whole solution was aqueous, let's assume for a second. I mean, right now water is in gaseous state. They've given you the equation as well. The other second important point that I said was that if there's an aqueous solution, then again you're going to ignore these moles for water. You're not even going to write. You're going to take it as one, because if the entire solution is water, and all these molecules are reacting and getting produced and getting consumed in a solution that's made up of water, then water has a lot of moles. Let's say it has, I mean, you have a big beaker and this thing is going on in that. Let's say it has 1,000 moles of water in it. Then the concentration of water would almost be a constant. Like if you have zero point 0.3 moles or slightly less than zero point 0.3 moles or slightly more than zero point 0.3 moles, it doesn't matter. If the reaction produces zero point 0.2 moles, what does it matter? I mean, the solution already has 1,000 moles. So a slightly extra amount of water produced or consumed is not going to affect the concentration of water. So whenever a solution is aqueous, water is taken as one as well. You can remember these 2 points. Solids are one, and if the solution is aqueous and the equation contains water, then water would be taken as one as well. It's going to be taken as a constant. So let's explore a few more, slightly more difficult questions. Um, One of the questions was actually very difficult. When the question came, probably no one was able to actually really solve this question correctly. Uh, this one is probably easy. I'm going to jump to the difficult question, and it's this one. Now, this question is all about this reaction, about this equilibrium. The question is exactly the same, but it's a lot more creative question. What they're doing is, I mean, you have to fill in the same table: initial moles, equilibrium moles. The middle column is missing. That's your working reactant, getting reacted, getting produced. That's what you do. Okay, so you have to, at the end of the day, you have to fill this column over here. So pretty much our goal is the same, except that there's plenty of moles calculations involved. Now the question is, and hopefully you remember this reaction from O levels. This is ethanoic acid, and it can be reacted with alcohols to form esters. And so this is an ester. This is water, right? So let me write this down. This is ethanoic acid. I think you should know what ethanoic acid is. This is the alcohol, and they're forming an ester, and a water molecule is produced, and they're in equilibrium. So whatever happens, uh, there's forward reaction happening, and there is at the same time there's backward reaction happening. So both things are happening, they're going on, and the first thing is you have to write the expression for Kc in this case. So we're going to write the expression for Kc. It's going to be product concentration, which is CH3, and CO2R, and the other one is water. Okay, the reason I'm writing water in the expression is because they haven't told me that it's aqueous. Okay, nowhere have they mentioned that it's aqueous. And the reactant concentration, which is CH3, CO2H, that's the acid, and the alcohol, which is ROH. Okay, remember this R in organic chemistry is generally used as a simplification. R usually refers to, it's a short for rest of the molecule. So a bunch of, I mean, we don't really care. It's a bunch of carbon and hydrogen bonded to it. So we don't really care how many carbon, I mean, we're not even bothered with it. I said, anyways, this is my expression for kc, and the units are clearly it's numerator terms and denominator terms, x into x divided by x into x. So that's all canceling out. So it's obviously no units. So that's the easy part. Now the next part is that an experiment to determine kc, a student placed together in a conical flask 0.1 mole. So this is the starting point. That he's added zero point 0.1 moles of ethanoic acid. It says over here that zero point 0.1 moles of ethanoic acid and 0.1 moles of an alcohol. So that's where the reaction initially starts. That's the position at which it starts. And after that, what does he do? And he added 0.05 moles of hydrogen chloride catalyst as well. Sorry, it's 0.005 moles of HCl. Now remember one thing, that HCl is a catalyst. So I mean, this is a catalyst. I'm going to write this down. So catalysts remain unchanged. So they're not getting used up. They're not getting produced. I mean, they're a catalyst, okay? So they don't bother with the equilibrium. They just speed up the equilibrium. So the catalyst has no other role except for speeding up the reaction. So there's 0.005 moles of. So there's 0.005 moles of HCl catalyst. And the flask was sealed and kept at 25 degrees centigrade for 7 days. And after this time, the student titrated. So this is your initial flask. And he added all these things. And then he sealed it for 7 days, right? So for 7 days, he did not open it. Now, in 7 days, some sort of reaction must have happened. There must have been some forward reaction. I mean, like these two must have reacted together to produce this. So the amount of alcohol and the amount of carboxylic acid would come down. And the amount of ester and the amount of water produced would be, I mean, there would be some amount of ester and water produced. And when they get produced, the reversible reaction would also start. And a time would come when the rate of forward reaction, the rate of backward reaction becomes equal. And that's when the quantity of the reactants and the products, it stops changing. Anyway, so we're assuming that after 7 days, an equilibrium has been reached. Now, after 7 days, the student does a titration. And he does a titration like the entire content. He's titrating it with 2 mole per dm cube of NaOH. Okay, so he's saying that after this time, the student titrated all the contents of the flask. So everything that's in this flask is being titrated with NaOH. And the volume of NaOH is also given. That the volume that's required, that's also provided. That's 22.5 cm cube. Right? So this is what's happening. And using this information, you have to somehow figure out what are the moles of each of the reactants and products in the equation. Now, the first part of the question is calculate the amount in moles of NaOH used in the titration. Now, you have the volume and you have the concentration. Achha, is this clear? Is this question clear up till this point to everyone? Heba, Rida, Sanjida, Minahil, is this clear?
Yes.
So right now we are at this point. And the first part of the question states is how many moles is this? So you can quickly find moles, concentration into volume. So if you do concentration times volume, it's going to be, what's the concentration? 2 mole per dm cube, and the volume is what, 22.5 cm cube? Cm cube. So it's going to be, this thing is going to be divided by 1000. Can anyone tell me what the moles are? Is it 0.045 moles?
0.045.
Okay, this comes out to be 0.045. So this comes out to be 0.045 moles. So I'm actually going to simplify my working. I'm going to rub off this concentration and just remove the unnecessary things. I'm just interested in moles. How many moles of NaOH did we add? So we added 0.045 moles. Now the next part is, remember NaOH is a base, right? Hopefully everyone knows that. NaOH is a base. So NaOH is not going to react with everything in the mixture. It's not going to react with the whole thing. Not with the alcohol, not with the ester, not with the water molecules. It's only going to react with bases, react with acids. So the two things the NaOH would react with is, one of them is the HCl catalyst that has been added, and the other thing is the ethanoic acid. So the NaOH is not, I mean, although you are titrating the whole container with NaOH, but the NaOH is not going to react with everything. It's only going to react with HCl. I said now HCl moles are going to remain unchanged. So NaOH and HCl react in 1:1. So out of these 0.045 moles, you know that 0.005 moles have definitely reacted with the HCl catalyst. Because it's a catalyst, it remains completely unchanged. Is this part clear to everyone?
Yes.
I said, so we figured out that the moles of HCl are definitely not going to change because it's a catalyst, it remains completely unchanged. So when I titrated with NaOH, the NaOH definitely must have reacted. I mean, we all know that NaOH reacts with HCl. But there's 0.005 moles of HCl. So if I added a total of 0.045 moles, 0.005 moles have reacted with HCl. So what is left? 0.04 moles. So what are they reacting with? I mean, they must be reacting with this other acid, which is ethanoic acid. So that means, because the whole mixture had two acids, so that means that at equilibrium, after several days, the amount of ethanoic acid that was present is 0.04 moles, right? So we can go and complete the table. That I know that at equilibrium, 0.04 moles of ethanoic acid is present in the mixture. How did I figure this out? I'm going to repeat everything. That we left the entire equilibrium for 7 days and then titrated with NaOH. These many moles were required. And then we figured out that NaOH is a base. So base reacts with acids. There's one acid over here, which is HCl. So we figured out that out of these 0.045 moles that have been added, 0.005 moles probably ended up reacting with HCl. And the rest of the remaining moles, they don't have any other option. There's nothing else that they're going to react with except for the other acid, which is ethanoic acid. So ethanoic acid moles must be 0.04 moles because that's the amount of NaOH that is needed, right? So although we initially added 0.1 moles, but when we titrated at equilibrium, we figured out that the amount of moles of ethanoic acid is 0.04 moles. So is this clear to everyone so far?
Yes.
So, Sanjita, is this clear? Okay. The rest is simple now. I mean, I did this in one big step. They had given you different steps. They had even asked you about writing an equation between ethanoic acid and NaOH. Okay, but we did it in one go. I said now the rest of the part is easy. It's the same. The only middle column is missing, so we can add that on our own. That you initially added zero point 0.1 moles. At equilibrium, you have 0.04 moles, so that means 0.06 moles have reacted, right? So if 0.06 moles have reacted, then these two react in the same ratio. So 0.06 moles of the alcohol must have reacted as well. So it's also going to be 0.04 moles. Like initially 0.1 added, 0.06 moles reacted, so you're left with 0.04 moles. And if 0.06 react, on the other side, 0.06 are going to be produced. Everything was 1:1. So this amount must be produced. So initially you add 0, but now 0.06 got produced. So you have 0.06 moles of this, 0.06 moles of this, and product over reactants, you can find the value of Kc. So it's going to be 0.06 multiplied by 0.06, and everything would be divided by 0.04 multiplied by 0.04. And you can tell me what the value of Kc is. I think it's going to be 36 divided by 16, hopefully.
2.25.
It's going to be 2 point. And the rest is, I mean, we can ignore this. This is organic chemistry. Part E. What would be the effect, if any, on the amount of ester formed present if all the water were removed from the flask and the flask kept for a further week? So it's about Le Chatelain principle. If you remove water, get rid of water, it's going to make more water. So more forward reaction is going to happen. I mean, if you remove water, the backward would stop immediately because you don't have water. So how would the backward reaction happen? So the forward is going to be favored, and in that way, more ester is going to be produced. So that's the answer to this particular question. As is the previous question clear to everyone? बाकियों को भी Sanjida, is this clear? Rida, Hiba? अच्छा, similarly, we can let's see if we can find another. I should try and solve this question and send this in right now. I'm sending this on WhatsApp as well. TK, everyone try and solve this question as quickly as possible. I think it's it's a simple question of calculating Kc. TK, any questions? Anyone? TK, if there are no questions, we can continue tomorrow then. TK, I'm still not very well. So try and solve this. TK, I'll be waiting for the answer to this. So, okay, take care. Allah
Allah
Hafiz.
Hafiz.